Hi, welcome back for another C# challenge. This one's called Steps in Primes. We'll get right into the instructions. The prime numbers are not regularly spaced. It's probably not a surprise to you. For example, from 2 to 3 the step is 1, and from 3 to 5 the step is 2, from 7 to 11 it is 4. And of course those were all prime numbers. So between 2 and 50 we have the following pairs of 2 steps primes. They list 3 and 5, 5 and 7, 11 and 13, 17, 19, 29, 31, 41 and 43. They list out some prime number pairs between that range, 2 and 50. We will write a function step with the following 3 parameters. You've heard me complain about this. Use good names for your parameters, then we don't have to mess with this G, M, N stuff that isn't very clear. But anyway, G is an integer greater than or equal to 2, which indicates the step we are looking for. M gives the start of the search. It was that 2 in the 2 to 50 range, and N will be the end of the search, which would be the 50 in the 2 to 50 range. So in the example above, step 2 to 50 will return 3, 5, which is the first pair of prime numbers with a step of 2 between the range 2 and 50. So this function should return the first pair, emphasis on first, of the 2 prime numbers spaced with a step of G between the limits M and N if these G steps prime numbers exist. Otherwise, null. We'll be using null since we're in C#. They give a couple more examples if you want to look at those. They have a very tight range here, 5 to 7. 5 and 7 are both prime, and they meet this 2-step. There's a difference of 2 between them, so you would return this. They're actually looking for a long. If you look at the method signature over here, a long array would be size 2. So you would make a long array with 5 and 7. Then we got 5 and 5. They're looking for nil. There's no 2-step. There's really no numbers in that range, right? It's the start and the end are the same. And then they have an example here of the range 130 to 200, looking for a 4-step, and that happens to occur with 163 and 167. You could look up a list of all the prime numbers if you wanted to convince yourself of that. I'll assume they got it right here in the instructions. See more examples for your language in tests, and we do have this sample test section we've been working with, and you can see a few more examples below. Those will of course fire when we hit the test button, and when we do attempt it'll hit it with a larger suite of tests that unfortunately we can't see. They have a couple of remarks if you want to go through those. Notice that 193 and 197 was also met that criteria, but it was not the first pair, so that wasn't the result. This next remark is especially helpful. This messed me up the first time I went through. I thought the primes had to be consecutive, but apparently that's not the case. So in the case of 6, 100, 110, which you'll see as a test down below, they're looking for the answer 101 to 107. Though there is a prime between 101 and 107, that's 103. But of course that's only a 2-step, but it's still valid, so you can skip the 103 and get your step size from the previous prime number and the next one. So I had to change the way I did it. It's good to know in advance so you don't make the same mistake that I did. And then they go on to talk about the difference between a step and a gap as they're defined for their challenges. You don't really need to know that here. If we get into the next challenge with gaps, we'll look at that there. So all that said, I think you have a firm grasp on what needs to be done. Go ahead and pause the video, try this one out, and come on back when you're ready. Okay, let's get right into it. First thing I'm going to do is something I pretty commonly do. You don't have to do this. I just sometimes write out the parameter names because they run a series of tests, and that way when I am looking at my other print statements, I can get a quick idea of which problem I'm on. So I could say something like, oh, you know what, Let's even take care of that other thing I don't like. Step. Enough of this GMN nonsense. Start and end. This looks a lot better, right? So we can say step. We'll just list our parameters there. Could be helpful for you if you're having trouble. List those three out. Okay, didn't have to do that. And then what's next? How do I want to go about solving this problem? I'm going to sort of make a collection of prime numbers. I'm going to run a loop from the start to the end, and then I'm going to look for the prime numbers in that range. I'm going to step through them incrementing by 1 and try to find all the primes in that range. And then I can sort of analyze those, check the differences between those to get the answer that I want. So before we implement all of that, obviously here a nice helper method would be something that can tell us if a number is prime or not. I think we've done that in previous challenges, but let's go ahead and make a helper method for that. It's of course private. This has nothing to do with people who use my step method, so this is my private workspace area, so I'm making it private. They don't need to know how I go about solving this problem. Is prime. And it keeps the class easy to use when I do that. I'll just call it n. That's fair enough for just a general number. That's a common name for it. Notice I use the type long because the range is defined that way, start and end. So to get our primes, I'm going to do it one way where I take the square root of n and then I just basically step down from there. That sort of represents the cutoff point where I don't need to keep looking for prime numbers because the factors repeat, right? So think about if you passed in 36 here, and if I just take the square root of it, I get 6. I'm just going to start at 6 and go down 5, 4, 3, 2, 1, checking the factors that way, and I'll cover them all, right? Because if I go down to 5, that's not a factor. 4 and 9 are, right? But I didn't need to go past 6 to get up to 9 and 4. 4 and 9, 9 and 4 are the same thing. So it's just redundant. So I'm going to try and be a little more efficient. So I'll start by getting the square root. If you haven't seen that, there's this handy built-in method called square root where we can get the square root of a number. I think I need the system namespace for that, for the math class. Let's go ahead and bring that in now. And then in my case, right, square roots don't always come out nice and even. So I'm going to take the floor of it. I'm going to round it down. It wouldn't make sense to round up because that would go too high. That'd be too high of a factor. So whatever result I get there, I'm going to take the floor of. So that kind of represents the highest point that I need to check, and I can just step down from there. So I'll say int floor, we'll call it. And then floor, I think, returns a double. So I'll convert. I don't need to work with doubles. I'm just going to use a simple loop. And we've seen this convert before to kind of jump between types. I'm going to use that again here. And then I'll just start at floor and go down from there. Maybe there's a better way to name that. We'll start with that. I is greater than, we'll say 1, right? That should be fine. And then I want to decrement I. Don't add to it like we normally do. So we're going to hit all the values we need to, and then, yep, we're returning a bool. It's a simple question, right? Is this number prime or is it not? And then we know that if n modulo I is equal to 0, that means I divided evenly into the original number passed in, which means it has a factor other than itself in 1, which is the definition of prime. So we know this is bad here. We're just going to say return false, right? Because it's got other factors besides itself in 1. And then if provided you survive going down, stepping down 6, 5, 4, 3, 2, 1, you never encountered anything like that, we'll just say return true. That should be a simple enough way. There's probably a better way to determine that, but this should work. Simple enough. All right, good. So now we can tell if a number is prime or not. So I'm going to make a list of these, and that's sort of back to that weird remark that I made where we can kind of skip over primes found. So I'm just going to have a list. I'll call it primes found, a new list of longs. We'll do that. And then let's make that loop that I was talking about. We're going to loop over all the values from start to end. Int I equals start. I is less than, let's say less than or equal to, I don't remember what the bounds said in the instructions, but I think that's right. And then we're going to increase each time. We're going to go through that 2 to 50, if you will. That was the example they gave us in the instructions. 2, 3, 4, 5, 6, all the way up to 50. So we're going to check all those numbers. And what I'm first going to do is check if the current number we're on is prime. If it's not really useful to us, right? So let's make sure that whatever we're dealing with is prime first. Okay, so if we get into this code block, we know we're dealing with a prime number. And so it's prime. I'm going to add it to the primes found, to our list there. Good. Then I'm going to check, like the first time through, we can't really finish the problem, right? Because we only have one prime number. Like in this 101 to 103, like if you hit the 101, you don't even have two numbers yet to return to. You can't even calculate a step, right? You just found the first prime number. So there's not much you can do there, but otherwise, after we've looped through this a couple times, maybe we're on our second one, I could say if primes found count is greater than 1. Now we have something to work with, right? We have at least a couple prime numbers. And so what I'm going to do in this case is I'm going to try to find an index. I'm going to try and find a value in our primes found collection such that the difference between the current prime number we have and that one in the collection, if I subtract them, that it equals the step size. We're going to check if anything like that currently exists. So I'll say int index is equal to primes found, and then list, with list I get this find index method. That's very handy. And you pass it a predicate, and it will tell you the first element, the first index where your predicate is true. It's going to start at the beginning of primes found and then return that index. So in our case, our predicate, we know how to do, we're going to pass it a lambda function. We've done a bunch of these now. I'm going to use n just to signify the parameter name. It's just some number, right? Primes found are longs, so n is just going to represent each one of those as we step through them one at a time from the start of the list. And then with that number, what do we do to check if it's what we're looking for? Well, we know that I, right, the current number, we know it's a prime at this point. We got into this code block, and we're going to say if I minus whatever value we're looking at in primes found at the time, which is n, if I subtract those, does it equal the step that we're looking for, right? And you should know that this find index method, if it goes through primes found and it doesn't find any elements that meet your condition, your predicate, it's going to return -1. So I can say if index is greater than -1, in other words, it found an element such that the subtraction of these two prime numbers is equal to the step size, then we can say that we found it, right? That's what we were looking for. We found the very first pair that meets the condition. So I'm going to say return new long, and inside I'm going to initialize it with the values primes found index, right? We got the index up here, and then simply I is the other prime. And okay, you don't really need the curly braces for one statement under an if, but they don't hurt either, that's fine. So yeah, in that case, we found it. And then similarly, if we go through this whole loop, right, we checked all the numbers from start to end, checked all the prime values encountered, and we never got to this case where we found the step size difference between two of the prime numbers. The instructions told us to return null. Let me make sure I got these lined up right. Yeah, that looks right. Indentation's a little bad in here. So we'll say return null in that case. So I think we have something to work with here. Remember, you can expand to see this a little bit better. I'm going to get rid of it in my case. It's a little excessive there. Even this method is running a little bit longer than I like in size. Remember, I try to minimize the number of lines. You could certainly do that as an exercise if you'd like. But let's go ahead and run this, see what we get. Using sys. Oh, I already know I'm going to get yelled at because look at this. I'm using the list type, and we didn't define that here. That's already made for us in system collections generic. We've seen that a bunch already. So now let's test. I think we have a good shot. Okay, cannot implicitly convert type long to int. Okay, so I did something bad. Oh, I think I see it. So it's good practice too for you to pause and try and fix the errors too. That's a very important part of engineering solutions, is to be able to correct errors that you find. So go ahead and pause the video if you want to do that now. One that I see that's definitely a problem would be that. Yeah, because start and end are of course defined as longs. And we know that they give us a little help, right? They told us it was on line 11, spot 22. You could have counted out the spaces. I'm not going to do that. There we go, now we're happy. And expand these, you could see the parameters there. We could see which step we were choking on, and then add some more console statements, right line, as necessary to really drill down and figure out the problem. But we hit green here, so that's good. I'll leave it at that. In fact, I'll even remove the, well, I'll run the attempt first. Okay, more green. Then they let you refactor. We don't want any, you don't want any log statements usually in your production code there. No sort of debugging statements to print. Feel free to make the method size a little bit smaller if you like. Make a couple other helper functions or member variables if you like. Otherwise, I'll probably just submit mine like this. They're going to make us attempt again because I changed the code. And green, our favorite color. So yeah, if you know what to do if you have questions, hit me up in the comments. Otherwise, I'm going to submit this. And as usual, I recommend just taking a peek through the other solutions that people submit. They can be very eye-opening and show you some new techniques that you may not have been thinking of. Otherwise, thanks for watching, and I'll see you in the next video.